Okay, so what you see here is a lizard. It's kind of hidden on the plant, but what I use the lizard picture for is for the compounds that are found inside of it. These compounds can be found in the DNA of the lizard. They can also be found in humans. Those are adenine, thymine, cytosine, and guanine, and they just keep the information for the lizard so everything runs all smoothly. So what you see next is this yellow flowered plant, and this plant and all plants pretty much do the opposite of what humans do. They will take in the carbon dioxide that we breathe out and in turn give us the oxygen that we need to breathe. And continuing, there is a dog. It is actually my dog. His name's Fox, but that's beside the point. What this dog does is whenever it releases waste, along with many mammals or really any animal that does this, it will release methane gas, which is CH4. So now you see a tree, and yes, the tree will produce oxygen just like the flowered plant, but what I used this picture for was to show photosynthesis, which is where the plant will take sunlight, and through a process it will produce glucose, and the glucose is the compound that will feed the plant. The chemical nomenclature for glucose is C6H12O6. This is a very large tadpole that I found in my creek, and the compound that I used for it is, I think it's pronounced bufotenin, and it's found in a lot of skins of reptiles, any kind, snakes, lizards, pretty much any kind of reptile. So some of the other names that can be found for this is called dimethyl serotonin mapping in 5-hydroxy in N-dimethyl 5-hydroxy tryptamine. There's a couple more, but those are the most common ones that can be found for it. So next is a molehill, and it's just a whole bunch of soil that a mole dug out to dig down in the earth and crawl through and everything. But what this molehill is made out of is a whole bunch of different compounds. It's actually a heterogeneous mixture if you look at it, because you can see the different little things in there. But some of the things you can't see in there are the oxygen, nitrogen, carbon dioxide. There's some proteins, and there's even some carbohydrates that make up this molehill. So next I took a picture of a creek, and this creek is what runs beside our house. And the main compound that is in this picture is the water that runs through it. And the water is H2O, which is 2 parts hydrogen, 1 part oxygen per molecule. And water is actually one of the most abundant compounds found on Earth. So next is a picture of some clouds, and it's still H2O, but I thought it would be really cool to show how water can still be in its liquid form but look so different. The clouds are just water molecules that are just all stuck together, and they form that formation that we have come to know as a cloud and we see all the time. And continuing, I took a picture of an anthill that was outside my house, and I took it to show the compound that is in ants. It's the venom, and all it is a bunch of amino acids. There's alkaloids, ternades, one of those, I don't know how to pronounce it, and polysaccharides. And there are actually a lot more that go into it, but those are the most common, and they're the basic ones for every venom in an ant. Finally, we have a picture of some rocks that I found by my creek, and mixed in with these regular rocks, I guess is what I'll call them, is some quartz. And the quartz chemical, one of the compounds in quartz is SiO2, which is silicon and oxygen. This is actually one of the most common compounds found in any kind of rock. No matter where you find it, in the desert, by a volcano, under the ocean, anywhere there's a rock is probably the compound SiO2.